Okay, let's start with a little bit of a warm-up, and let's take a look at remembering how to solve equations when we have this squared term in it. So if I have x squared equals 25 and I want to solve for x, then to get rid of a squared, we actually take the square root. Okay, so square root of 25 is going to be 5, right? Because 5 times 5 is 25. And it's going to be a -5. So we need to remember when you find the square root of something, it can be positive, but it could also be negative because -5 times -5 is a positive 25. All right, so let's take a look at this one. Square root of a -30. So can I find a number so that I multiply it by itself? I get a -30, and the answer is no solution. If you put this in your calculator and you tried to find the square root of a negative number, it would tell you error. And we can never find the square root of a negative number because in order to get to a negative, you have to have one number be positive and one number be negative, and therefore they're not exactly the same. So no solution. If I was going to solve this equation, I'd start by subtracting 7 on each side, and I get x squared equals 93. And then I would take the square root, and I'd take the square root. And 93 is not a nice number. It's going to give us a decimal. Let's keep it to 2 decimal places. So square root of 93 is 9.64. And of course, it could be a negative 9.64. So it's not always a very nice number. Sometimes it'll be a decimal. Excuse me. So one of the other things we can look at, of course, is labeling our parabola that we took a look at in the last lesson. So there's a whole bunch of information in a parabola. Let's start with the y-intercept. So my y-intercept would be right here where it crosses. That's at 0, 3. So that would be my y-intercept. My x-intercepts happen to where the parabola crosses on my x-axis. So right here at -3 and 0, and right here at 1 and 0. So B. Those are my x-intercepts. My axis of symmetry, remember, is that line that cuts it directly in half. And I can see that line happens right there. And so that's always written as x equals, and whatever the number is, so in this case, -1, that's where it cuts it directly in half. So that's C. And then we have a vertex. Our vertex is where like either the top or the bottom point happens. So in this case, because it opens down, we have a top point right here. Let's call that D. And it is at -1, 4. Okay, so right up here, -1, 4 is where my vertex is at. And is it a maximum or is it a minimum? Well, you have to look at your graph. Since this opens down, it's my highest point, so it is a maximum. Okay, so that's all the good stuff that we have figured out from last lesson. All right, today we're going to take a look at how to transform quadratics. So we're going to look at how do we move them all around, and we're going to use a program called Desmos to help us out. Desmos is a free site online, so if you go to www.desmos.com, it's a graphing calculator, and we're going to use that today to help us take a look at graphs. Okay, so let's start with just the very basic parabola, y equals x squared. So this is what we call our base graph. That means we haven't done any transformations to it at all. So if I'm going to do my table of values, so I'm going to sub in these values in for my x. So I would put in a -3 in for x, and -3 squared, so -3 times -3 is 9. And then if I put in a -2 for x, it would be -2 times -2, which is 4. And if I put in a -1 for x, I'd be -1 times -1, which is a 1. 0 times 0, 1 times 1, 2 times 2, 3 times 3. So there we go. All right, and if I plot these on my graph, I get a point here, And then at -2, it's at 4. And -1, it's at 1. And then 0, 1, 1, 2, 4, 3, 9. All right. And what we have then is this, oh dear. I can't get this to be prettier. Oh, I'm having a hard time. What happens when you start using a mouse to try to write on a computer? All right, let's go down and up. So that's what our base parabola will look like. Okay, now from here we can transform it. So when we say transform it, it means like we can widen it and we can narrow it, and we can move it up and down and left and right. So we really want to kind of see how that's done depending on the numbers that we add to this equation. All right, so let's go to Desmos. Okay, so go to www.desmos.com, and we're going to put in what we call sliders so that we can take a look. So here we go. So here's my Desmos. I'm going to go to Graphing Calculator. All right, so in here, I'm going to write AX, my exponent. My exponent is shift 6 squared plus bx plus c. And notice underneath it says add slider A, B, C. So all, I want all those to be sliders. Okay, so what was happening before if I put B at 0? Actually, it might be easier just to go in and put B at 0 and put C at 0. This was my base graph. So A is 1. This is my y equals x squared graph. Here it is. Okay, so let's just take a look. Let's leave B at 0 and C at 0 for now. Let's just take a look at what happens if I alter A. So let's move this slider up and up and up. And what is happening as we move my A value bigger and bigger and bigger? And then what is happening if my A value gets smaller, 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 closer to 1 or closer to 0? Well, there's 0 right on the line. Okay, look at that as a decimal, right? So if I start at 1 and then I move it backwards, what's happening to it? We can see it's getting wider. And if I put it back at 1 and then I go bigger than 1, it's getting narrower. Okay, so the A value is what we call our vertical stretch or compression. If I'm getting bigger, I'm stretching it out. I'm stretching it so that it's getting closer and closer and closer to that y-axis. Whereas if, let me start at 1 again, if I put in a number between 0 and 1, then you can see I'm compressing it. It's like I'm stomping it down. I'm widening it out. Now, if you go to the negative, which you can, it's the same thing. Other than, of course, it's flipped upside down. So we can see that if A is negative, it flips it up and upside down, where if A is positive, it's right side up. So that's kind of an interesting thing to notice. All right, let's leave A at 1. So what happens with B? Oh, look at this. This is very strange. Oh, it's kind of like looping around. Well, I mean, it's okay. It's leaving my y-intercept at 0. It's not changing that, but it doesn't really tell me anything that great. Let's leave that at 0 then. And how about C? What does C do? Oh, look at that. So C is actually changing. So let me just put B at something. All right. So C is actually changing where my y-intercept is at. And if I change C to 2, look at that. My y-intercept is at 2. And if I change C to 4, look at that, my y-intercept's at 4. And if I change C to a negative, I don't know, negative 3.8, it's at negative 3.8. So B doesn't tell us a whole lot, but A and C certainly do. So let's write some of this stuff down because I think it's pretty important. All right, so a general rule for A, we can say is if A is greater than 1, it's a vertical stretch. In other words, it's narrower, closer to y-axis. Whereas if A is in between 0 and 1, it's a vertical compression, which simply means that it's getting, ooh, okay. I want to put a little bit more space there. It is a vertical compression, which means it's getting wider, which is closer to the x-axis, widening it out. And then lastly, if A is less than 0, it flips it to open down. Okay, general rule about C is that C is the y-intercept. Pretty cool. So whatever that value of C is, that's going to be exactly where it's going to cross on your y-axis, which is pretty neat. Okay, so let's go back to our basic parabola, y equals x squared. We can use what's called the step pattern to help us graph this quickly without using a table of values. And so what that means is, notice it's like a step. You go over 1, up 1, over 1, up 3, over 1, up 5. And then, of course, the other side is purely symmetric, right? So it's the exact same thing on the opposite side. It's over 1, up 1, over 1, up 3, over 1, up 5. Remember I said we're going to use the fact that it's symmetric to help us graph, and then this would be over 1 and then up 7. So 1, 3, 5. It's how we kind of remember how to graph this, right? 1, 3, 5. So we can use this step pattern to help us even when we have transformations that are going on. Even when our graph has these numbers in our equation, we can use the 1, 3, 5 to help us out, and I'll show you how. Okay, so we want to draw a parabola that has the following properties. So first off, it has a vertex at 3, 5. So let's start there. So 3, 5 is right here. There's my vertex. We also know that this opens down. So we're going to go down. And then my step pattern, of course, is a 1, 3, 5, which means I'm going to go over 1, down 1, over 1, down 3, over 1, down 5. And that's really enough. So over 1, down 1. On the other side, over 1, down 3, over 1, down 5. And then let's try to draw a nice parabola through there. There we go. Okay, now we don't always have equations written in y equals ax squared plus bx plus c form. This is called standard form. It's a form where there's absolutely no brackets. But we do have this other form, okay? So a bracket x minus h squared plus k. And I'll show you why we like this form in just a minute. But we're going to go back to Desmos. And we're going to put this form into Desmos and then start playing with a, h, and k and see what we like here. So back to Desmos. I'm just going to click off of that, hit my x's. Okay, so we have a bracket x minus h bracket squared plus k. Okay, so start by putting a at 1 and h at 0 and k at 0. Okay, and this is our basic parabola. Okay, so basic parabola. So we should see if I alter a, if I go higher than 1, it should make it narrower. And look at that, it does. And if I go in between 0 and 1, it widens it out, right? And if I make it negative, it flips it down. So see how a, it doesn't matter what in what kind of form our equation is written, it's still going to have those same properties. So that's great. Okay, so let's leave A, let's say at, let's put it back at 1. It doesn't matter. I put it at a number, it doesn't matter. Okay, let's start playing with H. So I'm going to start with moving H over to the positive side. Notice when H is positive, okay, it's moving to the right. And as H, if I put it back at 0, okay, so starting back at 0, if it goes negative, it's moving to the left. Look at that. All right, so obviously this H value, what's in brackets, is going to affect our graph moving it left or right. So that's exactly what happens here. So let's put it back at 0. Okay, and then what happens with K? So if I go up, it goes up. If I go down, it goes down. So notice my K value moves it up and down, whereas my H value moves it to the left and to the right. And my A value is still making it narrower or wider or flipping it up and down. So that's awesome. All right, so let's write a few notes on this. Now, actually, let me go back to Desmos for just a minute. So let's put this at 2, let's say, and let's put K at -3. I want you to notice, you look at this, look where my vertex is at. So my vertex here is my lowest point. It's at 2, 3. It's right here. Okay, so 2, -3 right there. And if I move H, let's say over to -2, now my vertex is at -2, -3. And if I move this up, now my vertex is at -2, 2. So my H and my K are actually going to give me where my vertex is at. So I think that is pretty cool. So the reason why we like this form even better than standard form is because this form is called vertex form, and because it gives us the vertex. So let's write a few notes on that. All right, so let's start first if we have this plus K. So the plus K, so if K is greater than 0, so it's positive, it moves up. If K is less than 0, it moves down. Now, how about for H? Okay, so this is a little bit different. I just want you to know. The first thing that you need to do is when we're talking about H, H needs to come out of the brackets. So see how it's X minus H inside the brackets? So when we talk about the H value, it has to come out of brackets first. So out of brackets. And the way that it comes out of brackets is we take X minus H and put it equal to 0 and solve for H. So X would equal H. That means basically it's changing signs. So when it comes out of the brackets, it changes signs. Now, once you take it out of the bracket, if H is greater than 0, it moves right. And if it's less than 0, then it moves left. So we'll play with that one a little bit more because it has to come out of the brackets first. In other words, it has to change signs when it comes out of the brackets. And therefore, once it's out of the brackets, then you can look at, does it move it left or move it right? If there's a negative, then it opens down, right? So we saw that negative out front opens down. And if A is greater than 1, then it's a vertical stretch. And if A is between 0 and 1, then it's a vertical compression. Okay, so we can play with this a little bit more. So let's do some graphing. Let's say we had 2x squared plus 1. So 2x squared plus 1. First thing I want to do is I want to figure out where my vertex is at. Now there's nothing inside the brackets with the x, so that's going to be a 0. And then the constant number at the end is a 1. So 0, 1, which is right here. Then I use my step pattern. So my step pattern was a 1, 3, 5. But because we have this 2 in front, it means that I have to multiply all of those steps by 2. So 2, 6, 10, which means I'm going to go over 1, up 2, over 1, up 6. 1, 2, 3, 4, 5, 6. And I can't even get the other one in. So over 1, up 2, over 1, up 6. And then we have this parabola right here. And that's what caused it. That 2 caused that vertical stretch. It caused it to get narrower. It caused to increase our step pattern. So instead of 1, 3, 5, it was now a 2, 6, 10. Okay, let's do the next one. So my vertex is going to be it. Now, this is what I'm talking about. See how we have x plus 2 inside the brackets? When it comes out of the brackets, it's going to be a negative 2. And then at the end, I have no number, so 0. So this actually moved my parabola 2 to the left because it's negative once it comes out. And then I have my step pattern. Whoops. My step pattern, my 1, 3, 5. But because of this negative sign, it's like multiplying them all by a negative 1, which just means it's going to open down. So it's going to be a negative 1, negative 3, negative 5. So negative 2 and 0 is here. And then negative 1, 3, 5 means I'm going to go over 1, down 1, over 1, down. Whoops. Sorry, I'm trying. These are very small. Over 1, down 3, over 1, down 5, over 1, down 1, over 1, down 3, over 1, down 5. There we go. Okay, and here's my parabola. All right, let's go over here. So I have a vertex. So this, see that plus 3, it's inside the bracket. So when it comes out of the brackets, it's a minus 3, 3 to the left. And then I have this negative 5 as a constant. So it's going down 5. And then my 1, 3, 5 is going to get multiplied by negative 2. So that negative just means it's going to open down. And then there's going to be a vertical stretch. Okay. So negative 3, negative 5. Oh dear. 1, 2, 3. 1, 2, 3, 4, 5. It's going to be hard to fit this one in. Okay, over 1, down 2, over 1, down 2, over 1, down 6. I can't even fit it on there, but that's okay. I have a couple of points here. That's enough. And there. Okay. So that's how we use our vertex and our step pattern in order to draw some graphs. Just a couple more examples. So here my vertex would be at 1, 1 because the negative 1 when it comes out becomes positive. And then my 1, 3, 5, I'm going to multiply those all by 2, which becomes 2, 6, 10, over 1 up 2, over 1 up 6. 1, 2, 3, 4, 5, 6. And I'm definitely not going to get 10 on there. Over 1 up 6. All right. Here we are. This one is going to give me a vertex at negative 2, negative 1. Negative 2, negative 1. And then my 1, 3, 5 is all going to get multiplied by negative 0.5. So that means it's going to open down. Oh, we have these decimals. Oh, well. So over 1, down a half. Ugh. Over 1, down another 1.5. Here. Over 1, down 2.5. Then over 1, down a half. Over 1, down 1.5. over 1 down 2.5. Oh, it looks like it's something like that. Should put bigger grids. There we go. And then lastly, over here, we have a vertex. Oh, I should write that. We have a vertex at 4, -4. And our step pattern 1, 3, 5 is going to get multiplied by -2. So it's going to open down and it's going to be vertically stretched. So -2, -6, -10. So 4, 1, 2, 3, 4, -4 is right here. And then over 1 down 2, over 1 down 6. 1, 2, 3, 4, 5. That's probably right there. 6. Over 1 down 2, over 1 down 6. And we get there, right there. Okay, so that's how we graph it when it's in vertex form. And you can see when it's in vertex form, then it's so easy to graph, which is why we're going to really appreciate vertex form when it's given to us. All right, if you have any questions, make sure you come and ask me.